Hello, everybody. Welcome back to Earth Systems. We're going to get started here today with some information about the hydrosphere, which is, of course, the water on Earth. Let's see here. Okay, now, with this discussion, we're going to be talking about water and how it works here on Earth. We're going to be starting off relatively simple, but before we get into that, I just wanted to talk about a couple of things that happened over the weekend that relate to Earth science. A few of you may have heard about a volcanic eruption in Tonga over the weekend. There in the Pacific Ocean. Here we have an image of the Pacific Ocean with the sun reflecting there, very, very nice. I want to show you this right here. This is a GIF from the National Oceanic and Atmospheric Administration. And you can see that as the sun sets right here, there's a huge disturbance. That disturbance is a volcanic eruption of a volcano in Tonga. Yeah, huge amount of power. This volcano is just underwater, just barely. The very top of the mountain that the volcano makes is just a couple of small, tiny islands. But this eruption was pretty significant. I haven't seen specific numbers on the volcanic explosivity index value of that eruption. It was big. My guess is it would be somewhere around, I don't know, a 7 or an 8. It was a big eruption. Definitely not anything to mess with. Here is a high quality still of this image. Let me show you. From space, humongous eruption. So this is all dust and ash and also water vapor condensing. So this was the largest explosion ever captured from space. So pretty fascinating stuff. It also caused a tsunami. You can also see, do you see the shock wave there pushing the clouds out of the way? Seen from space. That shock wave traveled around the Earth a couple of times and was detectable all over the Earth. The sound from the eruption was also heard as far away as Alaska from Tonga, which is near the equatorial Pacific. So the fact that the sound could be heard in Alaska, and the sound was heard 8 hours later. So there was also a tsunami. A few people died. We don't have exact counts. Tonga obviously was most hard hit, but there are deaths as far away as Bolivia in South America, and some injuries here in the United States, fishermen and so forth, off the coast of California. So pretty crazy stuff, the power of volcanoes. So we've talked about that. Hopefully you've learned a thing or two about that. So moving on, we're going to talk about the hydrosphere. Okay, I really hope that I'm sharing my screen right now. Yeah, I don't know. Because it doesn't say whether or not we're sharing the screen. You are screen sharing, okay. But it doesn't tell me which screen I'm sharing. Okay, well, hopefully that just works. All right, now, we are going to talk about the hydrosphere, like I said. So I want you to think about a thought experiment. All right, you have the opportunity to go to the International Space Station. You're a human, you need water. right? They're off of the earth. There's lots of water down there, but very little water up here. How are you going to get water? They're not going to be, there's no pipes running down to the earth that you can just, turn your faucet on and the plumbing will carry the water all the way up. No, it doesn't work. So where do you get your water from? Well, some water is brought up from Earth, but water's heavy and it's really expensive to launch heavy things into space. So how are we going to get water, right? So you're an astronaut hanging out on the International Space Station. I think this is a great image. I really like this image here. This astronaut looking down the cupola of the International Space Station. Pretty cool. Now, the water on the International Space Station is recycled. So what does that mean? Well, the astronauts have a saying. Yesterday's coffee is today's coffee. That's right. They recycle their urine, as well as they pull air out, or water out of the air they breathe out, and they recycle it. I believe they recycle 92 or 93% of the water, which is amazingly efficient. And you're thinking, oh my gosh, that's so gross. They're drinking urine. Well, I have some news for you. So are you. So you know about the water cycle. This is fourth grade stuff, right? You know about this process: evaporation, condensation, precipitation, collection, and we go on and on and on, right? Well, guess what? This water is not just pure water. It has stuff mixed in, right? So in the oceans, it's salt water. So the water that is ingested by fish and mammals and birds and so forth that they urinate out ends up collecting in the rivers and in the ocean, and that water in the urine evaporates, condenses. The water molecules that you drink today have probably been through thousands of other humans. Bare minimum, hundreds of other humans and tens of thousands of other animals, as well as plants. Okay, so it's not like we don't drink recycled water either. So on the International Space Station, yeah, they drink recycled water, but we do too. We drink recycled water. This water evaporates, condenses, precipitates, collects, right? But it's not like this is new water every time, right? This water has been through living things. It's flowed over rocks. It's touched all sorts of stuff, right? Not to mention been in the digestive systems of other animals and human animals as well. So this is all recycled water, right? So I want you to consider that fact, okay? I want you to look at your water bottle or whatever it is and think about the individual water molecules that you're going to be ingesting. And those water molecules have been all over the place, right? There have been animals and plants that have ingested it and then either breathed it out or urinated it out. And that water then collects in the rivers and streams, goes to lakes and oceans and so forth, right? So you know about the water cycle, but I want you to really consider what the water cycle is, okay? It isn't just this fourth grade science thing. It's a very, very important process of water molecules and their travels all over the earth, okay? So I want you to write down that the water cycle is a water recycling system here on Earth. The water cycle is a water recycling system here on Earth. All right. And we get it in snow and there's all sorts of different forms. Over the next few days, we're going to be learning about water on Earth. and how it works, and in what forms it can be found, and how we study it and how we use it and so forth. Okay. Now, here we have some pretty simple graphics, right? Well, we've got a very beautiful lake here. If I'm not mistaken, I believe this is Crater Lake in Washington. I might be wrong about that, but these lakes, right? Beautiful, beautiful places, collections of water. We have a bunch of lakes here in Utah, all right? We've got Utah Lake and the Great Salt Lake and Lake Powell and so forth. But what is the difference between a lake and a sea? Well, not much. It really is just kind of the size, okay? The size of the body of water. There are many seas on Earth. Some of them are saltwater. For instance, here we have an image of the Black Sea. The Black Sea is a saltwater sea. I love these swirling current patterns. We'll be learning about currents here in a few days, right? But there's also many freshwater seas, okay? So you can't just say that a sea is saltwater and a lake is freshwater. That is not the case. Some saltwater, some lakes are, or sorry, some seas are freshwater. This is the Caspian Sea. It is the largest body of freshwater in the world in terms of geographical area. The largest in terms of amount of water, however, is a lake by the name of Lake Baikal, which I'll pull up an image here. Whatever. I guess we could use this one. If the computer will go. Lake Baikal. All right. This is the deepest body of fresh water in the world. We don't really understand how deep it is. It is very, very deep. It can be found in Russia, just north of the Mongolian border. Here you've got Irkutsk. Okay, here's the border of Mongolia. Here's Lake Baikal. Okay, very, very large lake. It's kind of skinny, but it is extremely deep. Okay, so we have lots of bodies of water, rivers, streams, lakes, seas, and of course the ocean. We'll learn more about the ocean later. There is one body of water that is not discussed very often, and I think it's an extremely important body of water. That is groundwater. It's not one continuous body of water, but there is a bunch of water underground. Okay, this is super important if you understand how wells work and so forth. Water is all over the place here on Earth. It is everywhere, really. It's impossible to avoid. Okay, groundwater is extremely important. We use groundwater for the majority of our water because what's nice about groundwater is it's pre-filtered. It goes through the layers of the soil and then the first kind of layers of rock and so forth. And as it does so, all of the contaminants get filtered out. And this is pure water, as clean as it can get under well, this one probably not because it's exposed to the air. But let's see here. But when it's underground, then obviously this is kind of a strange graphic, but I think it does the job. This is very, very clean water. very important for us as we use groundwater for the majority of drinking water and so forth. And that water comes from the lakes and the oceans and the rivers, but it seeps down into the ground, gets filtered on the way down, and then just sits on top of the bedrock. And it does flow. That's what's interesting. It does flow from the high ground to the low ground, just underground. So in some places there's like rivers underground, but in some places it just seeps through the rocks, seeps through the dirt. And it flows slowly, but it does flow. Groundwater is something that, when we talk about the hydrosphere, we need to think about more intensely. We need to think about that aspect of water. Because like I said, water can be found just about everywhere, right? It's underground, it's on the surface, right? In lakes and seas and oceans and rivers and streams. It's in the air in the form of precipitation, but also in the form of clouds, right? So it takes many forms, or we're going to be talking about those different forms. But today, what I want you to focus on is the recycling nature of the water cycle. Yesterday's coffee is today's coffee, okay? It just takes a little bit longer than it does on the International Space Station. We use the same water over and over and over again. All living things on Earth do. We find it in rivers and lakes and oceans and seas, right? Lakes, seas, the Black Sea, which is a saltwater sea, right? The Caspian Sea, Caspian Sea, which is a freshwater sea, and Lake Baikal, a freshwater lake, but again, lake and sea really kind of mean the same thing. A lake cannot touch the ocean, however, but a sea, where'd it go? A sea can touch the ocean, but doesn't have to, okay? In the case of the Caspian Sea, it does not touch the ocean, but it is a sea. So, but most importantly today, I want you to remember about groundwater. There's a bunch of water underground. It's pre-filtered, and it is, excuse me, and it does flow, okay? As it goes down through the rocks, it flows down, it gets filtered on the way. All right, huge amounts of water here on Earth, super important stuff. Here's what I want you to do. In the assignment that you found this video on, I want you to answer these two questions, okay? I want you to answer these two questions. Sorry. Question number one. Why is it important to understand the recycling nature of the water cycle? Question number one, I'll repeat. Why is it important to understand the recycling nature of the water cycle? So pause the video and answer that question. Why is it important to understand the recycling nature of the water cycle? And question number two, where can we find pure water, and why is it pure for drinking? Why is this water pure, and where can we find it reliably? Okay, so question one, why is it important to understand the recycling nature of the water cycle? And question number two, where can we reliably find clean water, and why is it clean? That's it for the video. Thanks for watching, guys. You're awesome.